Hello and welcome to the session. In this video, we're going to be solving question 31 of 2021 Senior Maths Olympiad first round. The question goes like this. The numbers from 1 to 100 are written on a board. In a single move, you choose 2, 3, or 4 numbers from the list, erase them, and adjoin the remainder of the sum of the erased numbers after dividing by 11. After a number of moves, we have 2 numbers left. If one of the numbers is 42, find the possible value of the second number. Right. Okay. So I think it would be good if I show an example of the kind of thing that's happening in this question. So let's say from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right. Then I said that in every move we choose either 2, 3, or 4 numbers, erase them, and instead of those numbers, we'll write the sum of the erased numbers. So let's say that we want to remove 9 and 10, for example. So in this move, we want to remove 9 and 10. So after removing 9 and 10, right, we're going to have 1, 2, 3, 4. So these numbers remain as they are. So 6, 7, 8. But then instead of 9 and 10, we're going to write the remainder when we divide the sum of 9 and 10 by 11. So if you add 9 and 10 together, you get 19. And the remainder when you divide this by 11 is 2, right? Sorry, is 8. So instead of 9 and 10, we're going to write another 8. So maybe in this step, we decide that we want to remove 7 and 8, for example. So if you remove 7 and 8, you still have the original numbers you had 1, 2, 3, 4, 5, 6, and then this last 8 that we got last time. So the sum of 7 and 8 divided by the sum of 7 and 8 is 15, right? And when you divide 15 by that will be 1 remainder 4. So instead of writing 7 and 8, you're going to write just 4. So this is the kind of pattern that is happening. So you continue like this. You keep on removing maybe 3 numbers, you add them together, find the remainder when you divide the sum of those 3 numbers by 11, and instead of writing those 3 numbers, you write that remainder. So that's how this thing works, right? That's the kind of thing that is happening in this question that we have. So now we're told that after a number of moves, we have 2 numbers left, and we're also told that one of the numbers is 42, and we're asked to find the possible values. We're asked to decide which of the numbers that we have, which of 24, 38, 47, 49, and 70 can be the second number. So the idea behind this question is that the idea behind solving this question is that the sum of the remainder when you divide the sum of all the numbers that you have by 11 is constant, regardless of what point you are at. Regardless of the point you're at in solving the question. So let's say that we have, let me start with a smaller example to describe this. I won't give a full proof. I'll just use this idea to solve the question, right? But I'll just describe how it works. So let's say we have the numbers 1, 2, 3, 4, 5. So the sum of these numbers is 9, 12, 15, right? So the sum of these numbers is 15. And when you divide by 11, the remainder will be 4. So the remainder at this point is 4. And let's say that we decide that we want to remove the numbers 3, 4, and 5, right? So once you remove these 3 numbers, if you add 3, 4, and 5, you will have 12. And if you divide 12 by 11, you have a remainder 1. So after removing these 3 numbers, what you will have at the next point will be 1, 2. And instead of 3, 4, and 5, you have just 1. And if you add these 3 numbers together and divide by 11, you still have a remainder 4. And let's say that you decide that you want to remove 1 and 2 at this point. On the next line, you have 1, and 2 plus 1 is 3. Divided by 11 will be remainder 3. So you have 1 and 3 at this point. And if you still add these numbers together, you have remainder 4. The idea behind this is that, let's say that you remove, like if you work backwards, right? Each number that you have here, each number that you added here is the same as the... So the idea behind this is that when you have a number, if you added a number at this point, right, that number you added were on the previous line. But then if you add those numbers on the previous line and divide by 11, you will have this in mode 11. So the number you replace a group of numbers with is equivalent to the sum of the numbers that you replaced on the previous line with that kind of thing. So that's kind of thing that is happening in this question. So the remainder when you divide by 11 at each point in the question is constant. So in the case of we have 1, 2, 3, 4, 5, the remainder will always be 4, right? Because when you remove three numbers, you're going to replace those three numbers with another number that is equivalent to the sum of those three numbers in mode 11. So that's the idea we're going to use to solve this. So to use this idea, we have to ask ourselves one question first. What is the sum? What is the remainder when you divide the sum of the initial numbers we have on the board by 11? Because you know that in the scenario described in this question, we're not working with 1, 2, 3, 4, 5. We work with numbers from 1, 2, 3, and all the way to 100. So now what's going to be the remainder when you divide this, when you add those numbers from 1 to 100 and divide by 11? So if you add numbers from 1 to 100, they'll give you, so 1 plus 2 plus 3 up to 100 will be 100 times 101 divided by 2, which is 50 times 101. Yeah, 50 times 101. So we want to know what this will be equivalent to in mode 11. So 50 times 101, let's write that here. So 50 times 101 will be equivalent to, so 50 in mode 11 is 6, right? Since 50 is 44 plus 6. So instead of 50, we're going to write 6. And then 101 in mode 11 is 2. Since 101 is 99 plus 2. So we're going to have this to be equivalent to 6 times 2, mode 11. And so 50 times 101 is going to be equivalent to 12, which is equivalent to 1, mode 11. So what this means is that if you add the numbers from 1 to 100 and divide by 11, right, the remainder will be 1. And remember, we said that this remainder is not going to change regardless of what point you are at in erasing the numbers. So if you have erased a total of 50 numbers, the remainder will still be what it was at the start, which in our case is 1. So now, we know the sum of, if you add at any point in this, in like at any point you are in performing the sequence of moves described here, that's removing numbers from the list and replacing them with others. If you add the numbers that you have together and divide by 11, you always have a remainder of 1. So since we know that, we can use that to now figure out which of these options, which of 24, 38, 47, 49, and 70 we can have together with 42 at the end of the sequence. So let's consider option A now. So they said 24. So if 24 is the second number that is left at the end of performing these moves, right? It means that at the end, we're going to have the numbers 42 and 24 on the board. And if you add these numbers together, you will have 70. Sorry, you have 70. And 70, sorry, if you add these numbers together, you have 70. And if you divide 70 by 11, you're going to have a remainder of 4. And remember that initially, that's when you have 1 to 100 on the board. If you add the numbers together and divide by 11, you have a remainder of 1. And we said that this remainder is not going to change regardless of how many numbers you have removed. So it can be, so 24 can be the other number we'll have at the end, right? So let's consider the second number, which is 38. So if 38 is the other number that we have at the end, so that means that at the end, we'll have the numbers 42 and 38 on the board. And if you add these two numbers together, you will have 80. And if you divide 80 by 11, you have a remainder of 3. And we're expecting a remainder of 1. So 82 it's not possible to have 80 as the second number. Sorry, it's not possible to have 38 as the second number at the end of, after performing these moves a large number of times, right? So the third one we'll consider is 47. So if 47 is the second number you have at the end, that means at the end you have 42 and 47 on the board. And if you add 42 and 47, you have 89. And then if you divide 89 by 11, right, you have a remainder of 1. So it means that we can actually have 47 to be one of, to be the second number that we have left after performing these moves like a large number of times, right? So C is the answer, but I'll just go ahead and show why the other answers don't work. So C is the answer, since if you have 42 and 47 left, the remainder will be, remember when you add 42 and 47 and divide by 11 will be 1, which is the same as what we had initially here. So if 49 is the last number we have left after performing this sequence a large number of times, it means that we're going to have 42 and 49 written on the board at that point. And when you add 42 and 49 together, you have 91. And 91 is 88 plus 2. So the remainder when you divide by 11 will be 2, which is not what we know, what we expect it to be. So D does not work. And if we consider E2, if 70 is the second number, then we'll have 42 and 70 at the end. If you add this together, you have 102. And when you divide by 11, you still have a remainder of 2. Right? So if you notice here, if 24 is the second number we have left, then the remainder at that point will be 4, which is not possible, right? Because remainder will always be 1, regardless of where you are at performing the operations described. And if we have 38 as the second number, then 42 and 38, if you add them together and divide by 11, you have 3 as a remainder, which is also not possible because remainder should be 1, regardless of where you are. That's the thing I described up here. So we can't have 49 as a second number, and we also can't have 70 as a second number. So from this, we can conclude that 47 can be the second number that we'll have on the board after performing this sequence of moves a large number of times. So yeah, that's how to solve question, I think 25 or so, question 31 of this exam. Yeah.